What did the planets of our solar system look like 3.8 billion years ago? Were they always the way we see them today? Or were they once completely different worlds? To answer these questions, we must travel back in time to a crucial moment in the history of the solar system, the end of a violent era known as the Late Heavy Bombardment. This period, which occurred between 4.1 and 3.8 billion years ago, was marked by an intense rain of asteroids and comets impacting inner planets. These collisions played a major role in shaping the surfaces and atmospheres of the planets we know today. Interestingly, the gas giants Jupiter, Saturn, Uranus, and Neptune have changed very little since that time. Because they do not have solid surfaces, most asteroids that struck them simply sank into their thick cloud layers. While some scientists believe these impacts may have slightly altered their colors by depositing minerals into their atmospheres, overall, the gas giants likely looked very similar to how they appear today. Their moons, however, may not have always been the same, as some like Neptune's moon Triton were likely captured later by gravity. The rocky planets tell a very different story. Mercury, for example, was once a scorching, violent world covered in countless impact craters. With almost no atmosphere to slow incoming objects, meteorites struck its surface relentlessly. At the same time, Mercury experienced volcanic activity that flooded large areas with lava, creating smooth plains. As the planet cooled and contracted, massive surface folds formed, leaving behind a landscape that reflects an extremely turbulent past. Venus, now the hottest planet in the solar system, was not always so hostile. Billions of years ago, it may have had much milder temperatures and even large bodies of liquid water. Comets likely delivered vast amounts of ice, which melted and formed oceans. For hundreds of millions of years, Venus may have resembled Earth, with conditions potentially suitable for life. However, a runaway greenhouse effect eventually trapped heat in its atmosphere, evaporating its water and transforming Venus into the extreme world we see today. Earth itself was also far from peaceful in its early history. After the bombardment period, the planet was extremely active, with constant volcanic eruptions, intense tectonic movement, and a thick atmosphere rich in greenhouse gases. Free oxygen was absent, and life as we know it could not yet exist. Over time, early microorganisms such as stromatolites began transforming carbon dioxide into oxygen, slowly changing Earth's atmosphere and making complex life possible. Mars, too, was once a very different planet. Scientists believe it had a thicker atmosphere, warmer temperatures, and abundant liquid water on its surface. Rivers, lakes, and possibly even oceans existed, making Mars one of the most promising candidates for life in the early solar system. However, because Mars is smaller, its core cooled quickly, causing it to lose its magnetic field without protection from solar radiation. Its atmosphere was gradually stripped away, and the planet became the cold, dry world we see today. The history of the planets shows us that change is constant. Worlds evolve, environments shift, and conditions that once supported life can disappear. By studying the past of our solar system, we gain insight into its future and a deeper understanding of why protecting Earth is so important, as it will not remain habitable forever.